Hi everybody. I came in, I had to find a new place to do videos today, so this is me in a different location. But today we're going to talk about the blood calcium homeostasis that's talked about in your chapter. So I wanted to cover the physiology of that today. This probably looks familiar to you as we're looking at the negative feedback loop that we studied in Chapter 1. We talked about negative feedback in relation to body temperature. We talked about positive feedback in relation to the labor contractions that are started during childbirth. So today I want to get into a discussion of blood calcium and all the different ways that our body actually helps to maintain the set point. Remember that normal level of what our blood calcium should be like. So as we go through this, remember the reason why we're on this topic today is that the matrix of our bone, remember, the extracellular matrix is filled with calcium crystals that are calcium salts that are kind of stacked or arranged along the collagen fibers. So calcium is actually stored in our bone matrix, and when we need to get more calcium, we pull it out of the bone matrix and into the blood. When our blood has too much calcium in it, one of the things we can do is we can put that calcium into the bone matrix and let it be stored. But we have a few other options here as well. So let's take a look at calcium homeostasis, and I need to say that my pen is not working today, so hopefully I'll get that figured out before the next video, but I'll give you a little indication here with the parts of the figure I'm talking about with this little dot. Hopefully that is going to work. So again, we start here with our normal blood calcium level, and we have two options. One, let's say that our blood calcium level gets too high. That means that we have too much calcium in our bloodstream and we need to find ways to really take it out of the blood and put it somewhere else. One of the major things that's going to happen is that our thyroid gland, which is a gland, part of the endocrine system here in our neck, is actually going to secrete a hormone called calcitonin. Calcitonin, secreted when blood calcium levels are high. So if you think about this diagram, calcitonin is at the top. So when blood calcium levels get high, that's when calcitonin gets secreted. And what it's going to do is it's going to stimulate calcium deposit in bone. Now the question I need to ask you is, what type of cells would be activated by calcitonin? Osteoblasts, osteoclasts, or osteocytes? The answer, hopefully you've already thought about it, is osteoblasts, because remember, osteoblasts are going to build bone, and you build bone by creating extracellular matrix and depositing that calcium into the matrix. So calcitonin is going to stimulate osteoblast secretion. That adds the calcium to the bone, that drops the blood calcium levels and gets your calcium levels back to normal. Now, maybe the opposite has happened. Maybe we have too much calcium that's been deposited, or we have a decrease in blood calcium levels for some reason, and now our blood calcium levels go too low. So here, another set of glands, these are called the parathyroid glands. They're actually little bitty glands that are embedded in the backside of the thyroid. They are separate glandular tissue, but they are in with the thyroid. So para means alongside. So parathyroid glands are kind of alongside, or they're attached to the thyroid gland. And when the calcium levels get low, the parathyroid gland secretes parathyroid hormone. So here at the bottom of the figure, calcium levels have dropped down low and parathyroid hormone gets secreted. Its job is to increase calcium levels in the bloodstream. So it's going to trigger osteoclasts to break down bone. These big osteoclasts actually, see all these little extensions on them? They're going to sit on the bone surface and secrete chemicals onto the bone surface that are going to dissolve that really hard matrix. They're going to liquefy it in a sense, and they're going to release all of the calcium from the crystals so that they can be moved or absorbed into the bloodstream. So parathyroid hormone down here will activate osteoclasts, which will dissolve the bone matrix and release calcium into the bloodstream, which increases blood calcium levels. So hopefully that makes sense to you. So parathyroid hormone is used when calcium levels get low, down here. Calcitonin is used when calcium levels are too high. And both of these are going to trigger cells within the matrix to do their job. If you have questions, please let me know, but hopefully that helped you understand about blood calcium homeostasis just a little bit more. Thanks.